Thank you so much for giving me an opportunity to talk today. And I was looking forward to come there, but thanks to visa issues, I couldn't make it. Today, let's talk about style memorization in diffusion models. In this slide, I kind of show how far we have come in last 10 years. We have made especially in terms of image generation capabilities, we made incredible progress. On the left side of the slide, we can see some of the generations from early GAN paper introduced by Goodfellow et al. These generations look somewhat realistic, but they are far from perfect. And on the right side, if you see some of the generations from latest flux model from Black Forest Labs, and as you can see, these models are capable of producing highly realistic and detailed images that can truly bring our imaginations to life. However, some of these models, actually many of these models, exhibit this one prominent failure mode, memorization. Since all these models are trained on this maximum likelihood objective, sometimes they tend to overly index on certain images or parts of the images, and they regurgitate parts of them in the inference time. Memorization is especially problematic because of the copyright implications associated with this failure mode. So before I proceed any further, I just want to emphasize we looked into this problem out of pure scientific curiosity, and today I'll be only sharing technical findings and how we kind of try to address this problem. I won't be diving into ethics and legal aspects of training these large models. Okay, cool. Over the course of last 2 years, I have done a lot of work in terms of this memorization, and especially content memorization. We kind of looked at how to find it, how to quantify it, and how to mitigate it, and so on. As you can see, in a couple of my papers from last year, I would say I even had a paper at NeurIPS last year. The content part, memorization part is sort of somewhat understood. However, style memorization is still a very new problem, and not a lot of work is done there. I actually looked at this one particular artist, Greg Rutkowski. He's one of the artists part of the image generator litigation lawsuit. And I just wanted to try to understand, all these artists are claiming the models are copying their style. However, it's not studied in a systematic way, in a scientific way. They're all saying this based on vibes of the generated images. So just wanted to see how different models are generating this particular artist. So here I show some of the original images from this artist, Greg Rutkowski. Here are some of the generations from some of the recent image generation models, Playground, NVIDIA Sana, Flux, and Stable Diffusion 3.5 large. The artist the prompt I was using is a painting. It's a dragon in style of Greg Rutkowski. My sister is visiting me, so I just asked her okay, so these are the original images and these are the generated images. So do you feel are any of the generations might have come from this artist? So this is the feedback I got from her. She's not at all associated with machine learning or any field. She's somewhat a creative type, so that's why I asked her. So she said these generations from Playground and Flux, they look like they are generated by this artist. However, these two generations, they are so far off that she doesn't think at least the generations are influenced by this artist's style. So that's the question we try to understand. So is there any way to automatically do this tagging instead of getting humans to rate the generation, say to see whether it represents an artist style or not? This is actually one of the preliminary results we have seen. I would say almost 2 years at this point in one of my first memorization paper, where we kind of just tried to generate some of the famous paintings by some of the artists. And as you can see, some of the in case of certain artists, especially this painting, The Starry Night by Vincent van Gogh, the models are able to actually memorize both content and style aspects. And however, for some of the contemporary artists or less famous artists, the model tends to retain parts of the style, but not the exact contents of this particular painting. The next question that arises is, are there any feature extractors that can actually extract the style well? That way we can study this problem. This is the trend we have noticed. Let's say this is the query image, and we have a bunch of the potential matches that could be there. And what we observed is most of the feature extractors, like the vision feature extractors, they tend to prioritize content over style. For example, if you take Dino or SSCD or SimClear, any of these models. In fact, they kind of are encouraged to not retain parts of the style because they apply these strong photometric augmentations that can destroy the style in an image and so on. To study this problem, however, we need a style extractor that could be prioritizing non-content parts of the image, where even a small bottom corner of the image, which is retaining only maybe these swirly thingies, we want this to be similar to the query image. Also, we also want our feature extractor to have the representations similar even if the content parts of the image are different, they have completely different subjects. However, they're painted by the artist using similar color palettes or something like that. Even then, we want those representations to be closer to each other. In fact, in my previous papers, I did not have to start from training a feature extractor itself when I was studying the content memorization aspects. However, for the style memorization aspect, we don't even have a good feature extractor to study this problem. So that's what we ended up doing in one of our recent papers. Most of the work is today I'm presenting is from this paper called Measuring Style Similarity in Diffusion Models, which appeared at ECCV this year. And these are all my collaborators who worked with me on this project. Let's jump on to what do we mean by style? Style is quite a subjective topic, and depending on the person you're speaking to, their definition of style could change. However, on a consensus of the style would be something like maybe the color, stroke, position and perspective could be certain things seem to be the common things. Most people kind of tend to agree on what it mean by style, and we needed a feature extractor that can actually encompass all these aspects and kind of have this numerical representation of a style for any given image. The main challenges we have faced in training this feature extractor, to study this problem, basically is first question is how do we extract style, and the second question is how to evaluate style. This topic is so understudied, at least the style feature extraction is quite understudied, that there are no standard benchmarks. Even let's say we trained a good feature extractor. Now how good is it? We don't know on which benchmarks to evaluate this on. We try to address these two things in the paper as well. The simplistic in terms of how to extract style, we introduced this method called contrastive style descriptors. It's a feature extractor model. Essentially, the two main contributions on training this feature extractor is first one is the training loss. So we kind of used something called multi-label contrastive loss. So essentially, this is kind of a merge of SimClear and supervised contrastive learning model techniques. Just to give you a sense, let's say this is a original image. We want the representation of it to be closer to another image from the same artist, and we also want this image to be closer to a very small crop of the original image, let's say a corner, and these two might or might not even retain the same subject. And lastly, we also want the representation to be closer to an image, a painting from a different artist. However, these two artists share a similar art moment, for example, in this case, post-impressionism. This is a kind of a loss. It can come from the same artist, it can come from the same moment, as long long as they share a style label, like we want the representations of these two images to be closer to each other. And also like for the self-supervised part, like we were careful in selecting the augmentations we are using. Like I said, like we used very large crops, and we kind of did like horizontal vertical flips. But however, we are careful to not to use the photometric augmentations like Gaussian blur, color jitter, because these can destroy the style in the image. And the second main contribution is the data set. The most common story these days is like just to get a really good data set that kind of solves most of our issues, which is exactly what we did. We kind of curated this data set called contrast styles. So we started off with like 12 million images from Lion Aesthetics data set. We kind of also curated like a lot of style tags, around like 3,800 style tags. We filtered out all the images with one or more of these style tags, and we deduplicated the data set and all that jazz. Like you can actually find this data set. We released it publicly for on the Hugging Face. Like feel free to check it out. So yeah, like these are the two main contributions for like training the feature extractor. And the next question is like, how do you evaluate how good this feature extractor is? So we introduced like two benchmarks. First one is like we have taken the WikiArt dataset, which was earlier curated to do the style classification. However, we kind of spun it off as like a retrieval task where we have a bunch of artists in the query split, and then we also have like some of the paintings from all these artists in the database split, and we want them we again like treated it as a retrieval problem. Like given an image, you want the model to match it to the same artist in the database split. And the second benchmark we introduced is domain net. In fact, like we kind of used the domain net in the opposite fashion of the task the data set was earlier introduced in. Like it was I mean earlier I think the domain net was introduced to say like, okay, if two grapes are there, whether they are clip art or realistic images, they have to be closer to each other or something like that. However, we used it in the opposite way. So we don't care about the subject of the image, like whether a grape or a watermelon, if both of them are clip arts, they have to be closer to each other. So that's the task. And as you can see, like the chance probability for the WikiArt dataset is like really small, like around 0.09%. And however, for the domain data set, the chance probability is around 20% because we could only get like 5 styles out of this data set. Okay, so lastly, like we kind of compared it against a bunch of pre-existing feature extractors trained in like a supervised way, self-supervised way. And as you can see, like our model does like reasonably well compared to like the existing feature extractors in terms of like style retrieval. And one important point I want to highlight here is clip is actually a very strong like existing feature extractor because it's not trained like a purely vision way. It's kind of trained along with the text, right? Like, so it has some style information already imbued into it. However, it's still lagging behind like the feature extractor we have trained. Okay, so then we kind of did like a error analysis on like the WikiArt dataset. Like we are getting around like 70%. How much is it? Okay, around 65% accuracy, top one retrieval accuracy, and then where are all the mistakes? Like where is the model getting confused? So we kind of so we also had these labels on like high level art moments for each of these artists, and what we noticed is the model is able to map it to the correct moment, but it's kind of getting confused when it comes to the exact artist. So one example I can say is like our model is consistently getting confused between Impressionist painters like Claude Monet, Gustave Le Seur, and Alfred Sisley. All of them painted landscapes, and all of them are Impressionist painters. Just the model is not able to assign the right artist, but it's able to map it to the artist from the correct moment though. And similarly, this is clearly highlighted in this ukiyo paintings also. Like see, there are no mistakes across the moments in this case. Like the ukiyo is a Japanese art style. The model is kind of assigning to a ukiyo artist, but not the exact correct ukiyo artist. And similarly, like for the off-diagonal elements, like we can see many of the post-impressionism and realism artists paintings are being assigned to the impressionist painters. And if you look at these art movements, it becomes apparent that all these three movements are closely aligned in terms of historical timeline and geographical location. So it's quite possible like these artist styles are very, very similar to each other. Yeah. So, here are some of the examples of generations. We have generated some images using the Stable Diffusion 2.1 model, and we compare like how our model performs compared to the CLIP model. Let's look at this example. This is extremely interesting. Like this is a painting of a dog in style of Leonard Afrimov. As you can see, like our model is able to map it to a painting of by Leonard Afrimov, like a woman, dancing woman, even though the subjects are quite different, like the model prioritized style and mapped it. However, CLIP model prioritized the content parts rather than the style parts, like it kind of mapped it to a dog rather than the correct artist. Okay, so the now that like we have a reasonably good feature extractor, the next question is like what to do next with it. So one of the important application could be like quantifying how much a generated image or a bunch of images are similar to a given set of original images in style of like a given artist, let's say. So just to give you a simple mental picture of this analysis we did, let's say we have a bunch of paintings, and these points represent like the representations, the style representations of these original images. And what we did is we simply computed like the centroid of the representations of original paintings. And similarly, we did the same thing for like the generated paintings in style of particular artists. And what we do is we have this prototypical representation of original paintings and prototypical representation of generated paintings, and just compute like dot product similarity of these two and see like if there is any trend to it. So that's what we did as an analysis. So for this analysis, so we kind of curated, shortlisted around like 100 artists from who predominantly appeared in Stable Diffusion Discord channel, and we computed these similarity scores, like how I explained in the previous slide, like just a prototypical representation of generated paintings and the original paintings. So on the x-axis, we represent the general style similarity, which is like where all the generated paintings, we are kind of using this prompt called a painting in style of fill in the blank, like the artist's name. And we also wanted to study like how, if we, let's say like if we constrain this prompt, I mean, right now, like a painting in style of an artist kind of gives a lot of freedom to the model, like it has a choice of choosing its own subject, like while creating this image, right? Like we also wanted to see like what happens if we constrain the model in terms of like content, and then how well can it generate this given style. So on the y-axis, we kind of represent the similarity score, where all the generated images are given a prompt, something like a painting of a woman doing some task. Like we kind of tried out like 4 or 5 variations to it. And again, in the style of this particular artist, like a fill in the blank for the artist. So two main things I wanted to highlight here is first of all, like both these similarity scores are highly correlated to each other. However, as you can see, like a bunch of artists like kind of deviate from this y equal to x line, and as you can see like if you actually go and look at these paintings, what I noticed is when the model is given the freedom of letting it choose its subject, it kind of tended to represent the artist style a little bit better compared to like constraining it to a particular subject. And also the second thing I wanted to point out is like I literally like went through all these 100 of these artists, their generations and their original paintings side by side, and this is what I kind of qualitatively noticed. Like all the artists about the generalized style similarity of greater than or equal to 0.8, a human, like most of the humans would say like the style has transferred, and this is typical of this particular artist style. And all the whenever the general similarity score is lower than 0.6, the style do not appear at all. Like I don't think any human would say like the style exists in these generated images. However, in between these two cutoffs, like between 0.6 and 0.8, I could not tell, like, because there are a few other artists who are also like exhibiting similar style. So I cannot confidently attribute that generated image has come from this particular is coming from this particular artist style. Okay, so the next step is like let's look at what's going on in this top right corner, guys, and then bottom left corner, guys. Like let me give you like a qualitative example here. So these on the left side we have three artists like with really high generalized style similarity scores. These are some of the real paintings from this particular artist, Leonard Afrimo. And here I also show like some of the generations from the models at the time when I was writing this paper. We have results from Midjourney, Stable Diffusion 2.1, Stable Diffusion 1.4. And here in this green box, like I show what are the generalized style similarity scores of this particular image with respect to all the original paintings of this particular artist. And as you can see, like most of these numbers are like greater than or around 0.8. And on the left side, we have three artists at from the bottom left, like with really low generalized similarity scores. I forgot to mention the previous study we did for like Stable Diffusion 2.1. So as you can see, like let's take the case of Greg Rutkowski again. Here, Midjourney seems to actually exhibit this artist style, like which is as reflected by this high similarity score as well. And similarly, Stable Diffusion 1.4 was also able to generate this particular artist style with a high similarity score of 0.83. However, Stable Diffusion 2.1 suspiciously do not have this artist style at all, with a really low similarity score of 0.48. I mean, it's clearly evident, like this image does not look like the original paintings at all. And the couple of other cases are Ruanzia and Amano. Both of them are surprisingly, they appeared a lot in Stable Diffusion prompts, but they don't appear in Stable Diffusion 2.1. So post hoc, this analysis, I just went into Google and Googled like, okay, what's going on? So I found this article. Turns out like Greg Rutkowski was actually deleted from Stable Diffusion 2.0 onwards models. So yeah, because and I couldn't find any news, but we hypothesized like a bunch of these artists are deleted from Stable Diffusion 2.1, either via unlearning or perhaps they kind of deleted these images from the training data itself. Yeah, so that was a kind of a little bit of a detective work we did. Okay, lastly, let's come back to this case study I have shown earlier. And these are some of the numbers I got using our feature extractor. And clearly, I mean, like my sister found these two images to be like potential generations from this artist, but these two were not. And clearly, like our model also reflects the similarity scores also kind of like correlate with like a human judgment. And we see like high similarity scores for these two images, however, very low similarity scores for these two images. So I guess we are a little bit out of time. So I'll just skip a few slides. And so I just want to mention like there are like a lot of directions that could be explored. I feel like understanding style and the style memorization itself is like a very new topic, and not a lot of work has been done on it. In fact, I feel like our paper took like just the first step. It's not the perfect model, nowhere close to the best feature extractor out there. These are like a few potential directions which I think are interesting. Like at the moment in our paper, we studied mostly one artist at a time in a prompt, and it's a much harder problem. Like, what if you have like multiple artists in a prompt and you want to attribute like the percentage of style in a generated image to each of the artists or something like that. And similarly, the metrics are also like just a first step into it. Like we don't have a way to do like automated style memorization detection at this point. This could be like a few interesting problems. So yeah, this paper, both the model and the data set are public right now. Feel free to check it out, and you can reach out to me if you have any questions or if you want to discuss further. Thank you.